time. We've all yearned for the ability to control it at some point in our lives. While the dream of unlocking space-time has long been deemed impossible throughout our history, can science break the confines of our present reality? And even if it is possible, do we possess the capability to achieve it? Perhaps to answer these questions, we must first delve into the fundamental nature of time itself. Can we truly begin to comprehend the essence of time? Most of us understand the concept of time as comprising the past, present, and future. However, physicists who study time have reasons to believe that our understanding of time might be limited. Our modern technology requires highly precise clocks, such as atomic clocks, which measure nuclear vibrations to tick 9 billion times per second. Without these accurate timekeeping devices, many of our technologies, including GPS, would be impossible. Yet when dealing with such accurate clocks, it becomes apparent that time does not flow as we traditionally perceive it. Time is not universal. The answer to what time is it change depends on where and when it is measured. While the Earth may appear static, it actually undergoes daily stretches and deformations. Although these changes are imperceptible with regular clocks, atomic clocks reveal that time behaves differently each day. When the Earth stretches further from its center, the clock ticks faster, and conversely, when it is closer to the center, the clock ticks slower. This dynamic nature of time is based on the specific space in which it is being measured. Imagine two 10-year-old twins are celebrating their birthday. As a special gift, each of them receives an atomic clock, and one of the twins is sent to Venus. Don't ask me why, a severe case of parental abuse, I suppose. Before they were separated, they planned to reunite over Mars for their 100th birthday. Assuming they both survive the passage of time and their clocks remain undamaged, the twin from Venus will find himself waiting for his earthly brother for a long time. Venus's surface gravity is approximately 91% of Earth's, which causes time to pass more quickly there. Additionally, Venus travels through space about 15% faster than Earth, further accelerating the flow of time compared to Earth. Consequently, by the time the twin on Venus reaches 100 years old, his sibling will still be in his late 90s. This phenomenon results from the difference in surface gravity and the faster travel through space on Venus, leading to time dilation, affecting not only the atomic clock but the aging process as well. How long will the Venus brother have to wait on Mars for his twin to also reach 100? Will it be a matter of hours, days, or even longer? It's challenging to determine without additional data and measurements. However, this scenario can help you grasp the complexity of time, which will persist even as we embark on planetary adventures. This behavior aligns with Albert Einstein's concept of space-time, which predicts the dynamic nature of time in different spatial contexts. This is the crux of Einstein's theory of general relativity, which suggests that heavy objects like planets and stars can actually bend and warp the fabric of space-time. In this way, time as we understand it is not just a ticking clock, but a flexible, malleable dimension that is influenced by the forces of the universe. This suggests that time travel is possible depending on the speed at which you travel and the gravitational forces in your vicinity. It also means that time passes slightly faster for astronauts in space than for those on Earth. Essentially, they are time traveling due to their speed and the distance from the Earth's core. How far into the future has the highest time-space travel taken us? A mere 48 milliseconds doesn't sound like much, does it? However, achieving greater distances in space-time will require far more extreme conditions. And don't forget, we are discussing a one-way ticket to the future. What about the past? In the early 20th century, instead of considering time and space as separate entities, Einstein proposed that they are intertwined in a four-dimensional space-time fabric. Einstein's theory predicts that time is intertwined with space, suggesting that space can exist in multiple places simultaneously. This implies that every moment exists at every possible time as well. The fabric of space-time, capable of being bent and warped by mass and energy, akin to the way a trampoline dips under the weight of a person. To us, the past feels like nothing more than a memory, and the future feels like our imagination. However, physics suggests that the past and the future are just as real as our present. Only from our perspective, the past is a memory and the future is a discovery. So if time is all around us, how can we travel from one point in time to another? Albert Einstein realized that time is the fourth dimension intricately linked with space. He managed to prove that space-time is curved, suggesting that in theory we only need a bridge or loops to navigate it. One of Einstein's friends, the renowned mathematician Kurt Gödel, was curious about Einstein's loops. And in 1949, he sought to determine if these equations permitted time travel. What he discovered was that if the universe were rotating and one could somehow remain still, it would theoretically be possible to access any point in time and space within the universe. However, we now know that the universe does not rotate. Despite this, his idea sparked further notions, such as the concept of a rotating cylinder creating a loop in time-space. Yet the construction of such a device would be more challenging than building the entire universe itself, making it an achievement we are unlikely to reach anytime soon. What if we don't have to create it ourselves? Perhaps there's a natural phenomenon that can warp space-time itself. No, that won't do if we want to make it back, or, stay alive. I'm talking about wormholes. We still can't prove their existence, although Albert Einstein predicted they exist, and if they do, they should be smaller than atoms if we ever want to use them. We'll have to figure out how to stretch them and then keep them stable to avoid catastrophe. The energy requirements for this are currently beyond our reach. However, theory suggests that exotic negative energy could be the key in the future. Negative energy is anti-gravitational. It can repel the fabric of space-time, preventing the collapse of the wormhole. But does this energy truly exist? We don't know. For now, the existence of negative energy remains a theoretical concept in physics, based on the principles of general relativity as proposed by Albert Einstein. Near a black hole, where gravity is as high as it can get, time operates differently compared to places farther from the black hole. If someone were to approach the edge of a black hole with high velocity, time would pass much more slowly for them than for someone standing still. This implies that while only a few hours might elapse for the person near the black hole, thousands of years could pass on Earth. It will be quite some time before we can embark on a journey to a black hole, let alone survive its radiation, heat, and all the debris that orbit the black hole. This feat is not something we will be able to achieve in the near future. In the distant future, we could potentially embark on space voyages to witness black holes up close and return thousands of years into the future to stay there. However, what might transpire if in the future we discover a way to travel to our past events? If such a feat is even possible, will we be able to change the past? Traveling to the past, if possible, can be confusing. Consider the well-known paradox of a person traveling to the past and preventing his parents from meeting. If he prevented them from meeting, he would never have been born, but then who prevented his parents from meeting in the first place? The concept of a multiverse could provide a possible answer without altering your past events. In other words, you may have prevented your parents from a different universe from meeting, not the ones from your own universe. The physical challenges, the technology challenges. Even if we could travel through space and time, could the human body withstand the journey? Experiencing extreme gravitational forces could have untold effects on the human body. Perhaps instead of focusing on whether we can travel to the past, we should consider whether we should. Ironically, it seems that time travel, if possible, will take us a very long time. For now, the best way to glimpse the past is by looking at the stars. The farther you can see, the further back in time you can peer. Curious to learn why and how? Watch the next video.